Well, first let me say how honored I am to be here and to share this happy day with you. So President Inan, trustees, deans, faculty, family, friends, and of course the graduates of the class of 2017. It is a delight to share this very happy day with you. To the graduates, I say congratulations on your achievement. Years of classes, papers, exams have all led to this happy occasion, and your last task is to make it past this one last lecture, my commencement address. To the families and friends of the graduating class, and to the faculty of Culture University, thank you for your roles in the success of the students. Now, commencement speakers sometimes feel the burden of trying to be eloquent and inspiring. I know better. We are more like the corpse of an Irish wake. We are needed for the ceremony, but no one expects them to say much. In a tradition of commencement speeches, I will pretend to give sage advice that comes with age and experience, and your job is to pretend to listen. As Oscar Wilde said, the only thing to do with good advice is to pass it on. It never is any use to yourself. So here's the advice. First, life goes by in a flash. Before you know it, you will be old. No one can prepare you for how quickly time will pass, except when listening to commencement speeches. Second, in your future life, cultivate a generous spirit. In all negotiations, don't bargain for the last little advantage. Leave the change on the table. In your collaborations, always remember that credit is not a conserved quantity. In successful collaborations, everybody can get 90% of the credit. My third piece of advice: as you begin this new stage in your lives, follow your passion. If you don't have a passion, find one. Life is simply too short to pass through without caring deeply about something. My passion was physics. More recently, I've gone into biology and biomedicine, energy, but physics has remained the core foundation of all those new ventures. When I became Secretary of Energy, the first 60 hours went to my day job, but in the wee small hours of the mornings and on weekends, I would write scientific papers with my research group. During my years of government service, I found that science became my most cherished hobby. And my final bit of advice: be bold and unafraid to venture into new areas outside your comfort zone. While a graduate student at the University of California at Berkeley, I worked on 3 experiments that were never finished. The 4th experiment took far longer than expected, and only after 6 years as a student and 2 more as a postdoctoral fellow, I finally managed to get the experiment to work. But it was not a smashing success, and the title of the paper called it a preliminary measurement. Surprisingly, despite that mediocre record, I was appointed an assistant professor of the physics department at Berkeley. What I mean to tell you is it's okay to fail, but if you do, fail fast and move on. Failing fast means you need to identify the critical things that are needed for success. Don't work on the parts that you're confident will work. Focus on the most challenging parts, and if you can't get them to work, look for another approach or move on. So when V.B. Koch founded the university in 1993, he said, "When we look around us today, we see that countries of the modern world are making rapid advances in all areas of science and are racing towards new discoveries in outer space. In order for us to close the gap in preparation for the future, we must educate our young people in the very best possible way." V.B. Koch was born in 1901 and died in 1996. When he was born, the existence of atoms and molecules was not proven. When he died, the foundations of the molecular basis of life were established, the human genome was deciphered, and the internet was exploding. Koch believed deeply in the value of education and the value of science. The prosperity of any nation is intimately tied to the education of its people, and the stability and resiliency of a democracy is strengthened by well-educated and prosperous middle class. Now, I agree that rapid advances in all areas of science are being made. When I was a child, in order to make a phone call outside a local area, you called a person, what is known as a telephone operator. You told her the number, and she connected you, sitting in front of a big board with many electrical sockets. Her job was to plug the wire that was transmitting your voice into one of the sockets of a big switchboard. Today, telephone operators have been replaced by electronic switches invented at Bell Telephone Laboratories. These switches are called transistors. 1 billion transistors are embedded into a single chip, a few square centimeters in area. My smartphone has the computing power 1 million times more powerful than the biggest NASA supercomputers that were used to land the first man on the moon in 1969. Computers, smartphones, and the internet have transformed our lives and connected us in ways that were unimaginable when I graduated in 1970, nearly half a century ago. And with all this information now at our fingertips, how are we dealing with the information? It turns out that sites like Facebook Newsfeed help us to follow the news by tracking our clicks and likes. The newsfeed gives us more links to keep us clicking. More clicks translate into more advertising revenue. However, in doing so, newsfeed algorithms create a bubble that reinforces our initial bias rather than presenting alternative views. And ironically, the same internet that has given us an ultra-connected world also is moving us towards a world of intellectually isolated tribes. So in my remaining time, I want to talk about two major problems that were unintended consequences of science and technology. The first problem begins with a story of an extraordinary scientific discovery. For the first time in human history, science is predicting how human actions will affect the world 100 years from today. We are changing the Earth's climate, and these changes are due to greenhouse gas emissions from human activity. These 3/4 of all those emissions have occurred since 1950. Now, climate change is not new. The Earth went through 6 ice ages in the past 600,000 years. However, recent measurements show that climate has begun to change much more rapidly. The size of the Arctic and Antarctic polar ice caps continue to shrink, and the glaciers in Greenland and Antarctica are melting much faster than was predicted 10 years ago. Increasing heat waves, torrential rains, and encroaching seas are other ominous warning signs. The Earth climate system is extremely complex, and there are considerable uncertainties in predicting future risks. The Earth has warmed up by roughly 1 degree Celsius since 1950, but the full extent of the damage we have already done will not be seen for 100 years. Now, why is that? The deep oceans are cold, and it will take that time to warm them up. Even if we stopped emitting all greenhouse gases today, that new equilibrium, again, will not be seen for a century. So from the geological record in the last warm period, the Earth was only 1 degree warmer than it is today, and yet during that time, the sea level was 6 to 9 meters higher. This is a matter of history, not a computer calculation. We used to believe it would take millennia for the sea to rise so much, but recent data suggests that it could occur in much shorter time. So for these reasons, mitigating the climate risks by decreasing our emissions is an prudent insurance policy. A changing climate does not respect national boundaries. There's a real danger that rising seas or collapsing agriculture due to heat and drought will lead to massive migrations that will dwarf the 4.5 million Syrian refugees. Roughly 800 million people live within 10 meters of sea level. We also face the specter of nonlinear tipping points that may cause more severe damages. For example, a tipping point is the thawing of the permafrost. The permafrost contains immense amounts of frozen organic matter that have been accumulating for centuries. If the soil melts, microbes will spring to life and cause this debris to rot. The difference in biological activity below freezing and above freezing is something we're all familiar with. Frozen food remains edible for a very long time in the freezer, but once thawed, it spoils quickly. How much methane and carbon dioxide might be released from the rotting permafrost? Even if a small fraction of the carbon is released, it would be greater than all the greenhouse gases we've released to date. And once started, a runaway effect could begin. Now, the second risk the world faces is a growing gap between wealthy people and the rest of society. Mechanization increased agricultural productivity and caused jobs to shift from farming to manufacturing. This change allowed a middle class to grow and thrive. But today, the middle class is in danger of being hollowed out. Machines with ever-increasing intelligence are displacing a growing number of jobs, and increasing economic disparity stokes unrest. Why are we not more concerned about these long-term serious threats to social stability, both climate change and automation? It's because these challenges don't appear as a clear and imminent danger. To paraphrase Carl Sandburg, an American poet, these risks are like fog, quote, coming on little cat feet. We also don't honestly confront a moral issue. When an individual risks their health by smoking, the consequences are borne by the smoker. The most innocent victims of climate change are those yet to be born. And so how can we continue our dependency on fossil fuels by passing on the risks to our grandchildren? There's another issue we face. Across all societies, customs, and religions, wealthy families have fewer children. The dilemma is that our current model of economic development is a mild Ponzi scheme. An ever-increasing young labor force has been used to support a smaller aging population. However, apart from immigration, the population of developed countries is shrinking. As developing countries become wealthier, they too will follow this pattern. Machines can provide many of the goods and services previously supplied by a younger workforce, and there will be means of increasing prosperity in a world of declining populations. But we also still need to create rewarding jobs that enlighten and enhance the quality of our lives and serve an aging population. While a daunting task, we must rise to the challenge. The solution is not to encourage families to have more children. Simply put, the earth has finite resources. In the short and middle term, jobs can be created by providing infrastructures that meet our clean energy needs. Policies could be devised that encourage people to save money by saving energy. The price of unsubsidized renewable energy is reaching parity with fossil fuel. And in the coming decades, clean energy is likely to become the low-cost solution for perhaps half our electricity and a good fraction of our personal and public transportation. But we need to do more. Wait a minute. 7. Aha. So we have to encourage investments in transmission, distribution, and storage systems that can fully utilize these lower energy solutions. So in the long term, however, we need you, the new graduates, to find a lasting solution. So I was extremely privileged to have been Secretary of Energy for the first 4 1/3 years of the Obama administration. And since returning to academia, my concerns about climate change have caused me to broaden my research and teaching efforts. In addition to working in biology and biomedicine, my colleagues and I are developing fast-charging lithium-sulfur batteries for electric vehicles, the ability to economically extract lithium from seawater, and the development of nanoparticle filters capable of filtering PM 2.5, the deadliest form of particulate matter. While my generation of scientists may not realize all our goals, I'm heartened by the fact that many millennials are keenly aware of these challenges and want to be part of the solution. In my party message to the young people graduating here today, I urge you to consider joining the effort to combat climate change. Now more than ever, we need you, talented young scientists and engineers, among us to create innovations. We need young economists and political science to work with the technologies to create better policy options. We need future business leaders that will make sustainability an integral part of their business. And finally, to the humanists, I ask you to speak to our common humanity. On December 10th, 1950, William Faulkner gave a Nobel Prize banquet speech about the role of humanists in a world facing potential nuclear holocaust. And he wrote and said, "I believe that man will not endure. He will prevail. He is immortal, not because he alone among creatures has an inexhaustible voice, but because he has a soul, a spirit," I'm almost done, "a spirit capable of compassion and sacrifice and endurance. The poet's, the writer's duty is to write about these things. It is his privilege to help man endure by lifting his heart, by reminding him of the courage and honor and hope and pride and compassion and pity and sacrifice which has been the glory of his past. Graduates, you have an extraordinary role to play in our future. As you pursue your private passions, I hope you will also develop the passion and the voice to help the world in ways both large and small. Nothing will give you greater satisfaction. Please accept my warmest congratulations. May you prosper and help save the planet for your children. Thank you.